All right, welcome back. Now we're on the fourth exercise, fourth video, 4 module 1. Now in this one, they want us to do some math calculation. And we're going to acquire some value from the user. We need to use pi. So how do we get the value for pi? Well, that's math.pi. How do we get math? We import math. So let's go ahead and do that housekeeping straight out of the gate. So we've got our import. I need to acquire something from the user. So let's go ahead and do our request inputs. And you know what? Let's do our traditional code blocks in here. Compute results and display whatever the result's going to be. Okay. So we've got that part, our overall templated format. What we're going to do is laid out. So the input, I need to get iterations. They said enter the number of iterations. Well, I'm going to say iterations equals, I'll get the input number of iterations, and I'm going to typecast that to be a whole number, not a fractional number of times through it. Now, from there, so what I'm going to do is this compute result part. To come in here, essentially, what we're going to do is the number of iterations. Let's do what we did in the previous with a loop. Create a for loop. For count in the number of iterations. So in the range of iterations, that's how many times we're going to do whatever we're doing. We're going to come up with a variable. I've got to define it just like we did last time. I've got to define it before I can use it like this. But I want the numerator, denominator, and then I've got to have this variable. We can call it whatever we want. But for what we're doing, we're going to declare them and initialize them. All right. So for this, inputs, think about it relative to the algorithm. Inputs could be something that are predefined or defined by the user. Inputs defined by the user, predefined. Calculation, output. So here's the calculation that we would have to do for what they want here. Okay. And based on Leibniz's method for coming up with pi. So let's go ahead and do the two displays. They've got two displays they want us to have. So the approximation is going to be the value of pi over 4, divided by whatever that was. So it's going to be pi over 4 times, the result will be pi over 4 times 4. So the approximation of pi is pi over 4 times 4. And we'll compare that to the original 4. So we've got an approximation of pi and whatever the math library says pi is. We go ahead and run it. Number of iterations that we go through this, well, they said 3 in their example that they gave us over here. See, 3. Let's go ahead. Oh, excuse me. Let me hit the wrong button. I should have hit enter. 3, enter. Approximation 3.46666667. Yep, that's there. And this rounded down a little bit where mine did not. Let's see if that's an issue. Now they give a little comment down. Where did I see it? Right here. This lab will grade the result to 15 decimal places. It looks about the same. So let's go and run it. Cool, all worked. Now, one of the reasons why I do these videos is things like this. I don't want you to spend time getting stressed out over, I don't know who Leibniz is or what's that all about. You could have gone and Googled it, figured out the calculation, but the calculation is not the important part of this. It's understanding what we're doing in 1, Python, 2, the algorithmic logic of what we're doing, and 3, we're using a structure, a for loop, to get through something a number of times. So we're good on this. Let's see you in number 5.